Welcome back to Math 263, and here we're going to take a look at section 10.7, the ratio test and the root test. Now the key idea is we're going to be given a series here, series from k equals 0 to infinity of the a sub k, and the goal is to compare it with a geometric series. Now there are two ways we're going to think of a geometric series. One of them, right, if you think about a geometric series, let's say the sum from n equals 0 to infinity of a constant times r to the n, right? That's what I want you to think about. If I take the ratio of two subsequent terms, I'm going to get this common ratio r. I'm going to stick absolute values here because the criterion, right, if you remember our geometric series, the geometric series converges if and only if this absolute value of r is less than 1. Right, so that's why we're looking at these absolute values, and that'll prove to be quite useful in understanding these series. And so the ratio test, the idea is we're going to look at the ratio of two subsequent terms, the n plus first term over the nth term. If we're with the geometric series, we're going to get, honest to goodness, absolute value of r. We'll see in a second that for the ratio test, the object we're going to look at is the limit of this as n goes to infinity. Okay, the second way we have of characterizing a geometric series is by looking at the nth root of the nth term. And if you think about what that is, right, if I take the nth root of c times r to the n, we're going to get the nth root of this constant c, and we're going to then multiply that by r. Well, this thing right here is just going to go to 1. So that coefficient in front is not going to be important as n gets large, and instead this nth root that we're going to look at is going to converge to the absolute value of r as n goes to infinity. So these are going to be the two sort of descriptions of the geometric series that allows us to understand what happens here in this ratio test and the root test. So recall, what is the point of a convergence test? A convergence test takes as input, it takes a series. So here we have the series sum n equals 1 to infinity of a sub n. And the question we're trying to answer is, does this series converge, yes or no? And the possible answers from our test is yes, it converges, no, it diverges, or the test is not powerful enough to address the problem, right? So it's inconclusive. Okay, so let's talk first about the ratio test. Okay, so given our series sum n equals 0 to infinity of a sub n, what we're going to calculate is we're going to calculate the limit as n goes to infinity of the ratio of the n plus first term divided by the nth term. Right, so that's looking an awful lot like what we saw in our characterization of the geometric series, except here we're taking a limit. And now there are three possibilities. Either this limit is strictly less than 1, in which case the series converges. This limit can be equal to 1, in which case our test is inconclusive. And the last possibility is that this r is greater than 1, in which case the series diverges.